Hello students, and welcome to another video. Today we're going to be discussing the cause of reactions. So why do reactions occur? So in one of the demonstrations I did in class, we took an oxygen or a balloon that was filled with oxygen and hydrogen gas, and they weren't reacting readily. It was just they were safely in a balloon. But once I applied just a little bit of heat, it went off. It exploded, okay? And what was causing that reaction to occur? Well, it was energy being added to the gases for them to break apart and combine. So let's go into understanding what's going on when I apply heat to the gases in the balloon. So we have two concepts here. I want you to write down these definitions. So one is the collision theory. Okay, it states that bonds are broken when molecules collide with enough energy. Now, all atoms are vibrating or moving, and in a gas phase they're moving very fast and they're taking up a lot of space, okay? And oxygens and hydrogens are moving around very quickly around each other, but they're bumping into each other, and it's kind of an elastic bouncing off of each other, but there's not enough energy to break the oxygen and hydrogen bonds. But when I add heat to the gases, what do the gases start doing? They start vibrating faster, right? Because that's what temperature really is, right? Temperature is just how fast the molecules are moving. And if they're moving faster, what's going to happen is they're going to bump into each other with enough force to break the bonds to form water molecules, okay? And the speed at which this reaction takes place is called the reaction rate. And we've talked about this in solutions, I believe in chapter 4, we've talked about this, or 5, before. We talked about solutions and how we can speed up solutions. We dissolve salt in water, and there's 3 ways to speeding it up, right? We can heat it up, cause the molecules to move faster. Okay, and that's what we did in this experiment here. You can mechanically move them faster by stirring the solution, or by decreasing the surface area for the atoms to interact with each other to have that reaction occur. Okay, so those are the other ways of doing reaction rates, and that's kind of a review from last time. But collision theory, they're not moving fast enough to break apart. Now they're moving fast enough to break apart, and then they form new compounds. And when they form new compounds, it releases a great deal of energy, okay? And that's based on this graph over here, right? If we had something over here of hydrogen and oxygens, okay, it takes some energy to break them. So we're gonna put energy in, because energy is gonna be taken from the surroundings. And then when they form new bonds, they come down further than the reactant side, okay? Let me draw this out. This might be easier to see. But keep this graph in mind. This is what we're doing. We're graphing out that energy. Over here. Okay, so we've got our chart of chemical potential energy and the direction of the reaction. And we've got our reactants, which is oxygens and hydrogens. They're not doing anything, but if we add energy, energy is added to the system. Okay, it's going to come up to a point where now all of the bonds are broken. We have hydrogens, and we have oxygens, and they're not bonded anymore, okay? And then eventually this graph will come down over here. And as it comes down, energy is released, and it's going to be forming H2O, and there's 2 of them, all right? And if you notice, the reactant side, it shows this curve of them taking in energy, breaking apart, and then forming a new substance. But if we look at just the net change, right, we're not going to look at the curve, we're just going to look at where it's starting and where it's ending. It's going down, it's becoming negative, and that means it's releasing energy. So if I come back to this picture, okay, this is not showing you the energy that was put in the reactants afterwards. It's just showing you the net change, okay, and then this net change is -7, okay? So it's going to be releasing energy. And with water being formed with hydrogens and oxygens, it's much greater than -7, okay? It's a lot more explosive, and it happens very rapidly. So if we look at those 2 examples, we've got one here that is showing them reacting slowly because the temperature is lower, but once we increase that temperature, the speed of the molecules increases. Do you notice how the speed's increased by the tails of the hydrogens and oxygens? And they're colliding more frequently, and we have more water molecules floating around, okay? So the speed of the reaction is increased by temperature. And how did I increase the temperature? Well, I put a flame by it, and it caused that chain reaction to occur. And it kind of goes through very rapidly, because just the reaction of forming water releases energy too, and that makes the other atoms around it go faster. So it's kind of a chain reaction that occurs. Okay, and I think that's it for this chapter. But that's the idea of what causes reactions and why that balloon was so explosive and it released so much energy. Okay, thanks for watching.